All right, cool. I think most people are here, so I think we'll go ahead and start. Thank you guys so much for coming. My name is Ariba. I am an M1, and I'm super excited for this. The whole MedML team is really excited. The purpose of this workshop is to basically give people a background on what machine learning is and how it works. There's like no code required. There's really no prerequisites at all for this workshop. So there's also like no dumb questions. If anything is confusing, please ask. This is for you. Like, ask clarifying questions. Cool. Yeah, I have been asked to do a disclosure just because we're going to be using some products from Google. I guess you should know that I used to work at Google as a software engineer, so I may have some like bias around those products. So yeah, although the product that I worked on was not any of those, I used to work on machine learning platforms at Google where our goal was to make machine learning easier and more accessible for everyone to use. So this is something that I've been passionate about for a long time. The whole MedML team is really passionate about this. So we're really excited to share this super cool and powerful technology with you guys. Cool. So let's get started. Okay, so the learning objectives for today, again, are to understand what machine learning is, how machines learn, because I think that's something that's confusing for a lot of people. Was confusing for me, like what does it mean for a machine to actually learn stuff? Like how does that work? And then like most of it is going to be the interactive part, where we're going to be training a simple machine learning model. So that should be pretty fun. Okay, and you'll notice this is just 5 minutes, so lots of time for questions and like conversation. Cool. So yeah, so the first LO is what is machine learning? So we want to go through just like some words that you've heard and define them a little bit. So artificial intelligence and machine learning are probably both words that you've heard. And so machine learning is a type of artificial intelligence. And so the thing that separates machine learning from AI is that AI can include things that are just like rule-based actions from machines. So for example, like a Roomba. Like if you were a Roomba engineer, you can program a Roomba by just telling it like some simple rules. Like if you hit a wall, turn left or turn right. If you like see some stairs, don't go down the stairs. If you're running low on battery, go back to your like charging station. Pretty straightforward. And other things, simple games like Pac-Man, like where do the ghosts like go? Like you can train, like teach them where to go by just like telling them some simple rules. Like if Pac-Man goes up, the ghosts go up. But machine learning is different because it's not rule-based. You can't, this is for problems that are like more complex and you can't solve them with just like a list of rules like you can with the Roomba or the Pac-Man ghost. So essentially machine learning is when you teach a machine to do things, to learn complex patterns, and those patterns are learned by example, not by rules. So does anyone want to like throw out like examples of AI or machine learning that you've seen in your day-to-day life, and we'll think about like, are those machine learning or are they like just general AI? Just shout them out.
Text recognition.
Yeah. Anything else?
Recommended videos on YouTube.
Yeah, that's a big one. Cool.
Online chatbots.
Yeah, great examples. I think most of those are examples of machine learning. So here's one. If you like have seen this on Gmail or any other email service, when you like get an email and it recommends like ways to respond to that, like think about if you were programming this feature, like this is pretty complex. You can't just like have a basic list of rules that can like come up with these things. So the way that this works is they like show the email service like a whole bunch of like past emails, and they're like, this is how humans talk to each other, learn these complex patterns by example. And we're going to get into like how a machine can do that, like how it can learn by example. But just the point to note here is that the difference between machine learning and AI is that we use machine learning for things that are more complex and can't be just like described simply. So like things like self-driving cars, like virtual backgrounds on Zoom, like how does Zoom know what pixels on a screen are like important and represent a person and which are just like the background and should be removed. Okay, does this make sense?
Ariva, can I ask a question?
Yes.
So like one thing I'm a little confused about, like isn't machine learning, like can't it be thought of as just like a more complex AI, like it says not rule based, but like the email suggestion, like isn't the way it's coded, like if the person says the words can't make it, like reply with this, isn't it just a lot of more rules? or is it more complicated than that?
That's an interesting way of thinking about it. I guess the important distinction is no human told it that if you see the words, can't make it. The machine like came up with that rule by itself. So it may have like somewhere inside its like machine learning mind, it may have that like connection where if a person says like the word like they're clearly like upset or something.
Right.
But if you sat down and made a list of those rules and fed them to the computer, that would not be machine learning.
I see. Okay, that makes sense.
Cool. So yeah, if you think about it, actually what we just did here is like two different types of learning. So where I gave you these definitions, like these words here, that's rule-based learning. And if I had just given you these examples and kind of let you figure out the pattern on your own, that would be example-based learning, kind of like machine learning. So we, like as humans, we do both of these types of learning. We do learning where we're just like told how a thing works, and we do learning where we like see examples and we kind of figure it out on our own. And so we can use, like we can have machines simulate those two types of learning as well. Okay, and we're gonna like getting into like how the learning by example actually works is LO number 2. But does anyone have any questions before we move on to that? Okay, that was a good question, Sammy, thank you. Okay, actually, yeah, so one other thing, you may have heard the words neural networks and deep learning. I just wanted to mention those. We're not gonna get into what those are, but those are both types of machine learning as well. So today we're focusing on machine learning, but just a fun fact, the machine learning algorithm that you're gonna be training later is actually a neural network. So yeah, but we won't talk about like how that, like what that means today. Okay, great. So now let's talk about what it actually means for a machine to learn by example. How does it do that? Okay, so to understand how machines learn, we're first gonna think about how babies learn. And this may not actually be like how real babies learn, but it like will be helpful for understanding how machines learn. So this is a picture of me as a baby. Just kidding, it's a stock photo. But okay, so if we think about how a baby learns what a dog is. So the first time a baby sees this picture, it doesn't know what a dog is, but it's like mom or something tells it, this is a dog. And it's like, okay, let me try to like understand what the word dog means. So maybe the baby's understanding of a dog is something that's brown and fluffy. Okay, so it goes back out into the world and it sees something else that's brown and fluffy and it's like, that's a dog. And its dad is like, no, that's a squirrel. That's not a dog. And so the baby's confused for a second, but it's a smart baby. So it's like, okay, let me go back and like modify my understanding of what a dog is so that it works for both of these animals. So now maybe it says, okay, a dog might be something that's brown, it's fluffy, it's got big floppy ears. Okay, it goes back out into the world and it sees another dog, and this also doesn't fit its definition of a dog, so it changes it again. It's like, okay, maybe a dog doesn't have to be brown, it can be brown or black. And it'll go back out into the world, see some more animals, and if this definition still works, which in this case it does, because these cats don't have floppy ears, so it knows that these are not dogs, then it won't change its definition. But if it sees something else, like say it sees a German Shepherd and it's like, what the heck is that? And its parent is like, that's a dog too. Then the baby understands that like, oh, like I guess dogs don't have to have floppy ears. So it'll change its definition again. So we can see how the baby like is taking in these data samples of like things that are dogs, things that are not dogs, and coming up with possible definitions of what a dog is. And then if it's wrong, it'll go back and change it so that it can be like more accurate. Yeah. Okay. So now let's think about how this would be different for a baby machine. So we can do a similar thing with machines where we'll just show our little baby robot here a bunch of pictures of dogs and not dogs. And what the machine will do is kind of similar to what the baby did. It'll generate a bunch of like possible explanations for this, like possible definitions of dog and not dog. And then because it's a machine and it likes numbers, it's going to go and quantify how good each of these definitions were. So for the first one, like this was pretty bad. It was only accurate like 50% of the time. It's not very good. And then it'll check like, how did we, like with our other definitions, how did we do? And so you can see how like these definitions were like slightly more accurate. It's getting more and more accurate the more data that it sees. And so when it's done being trained, it'll be like, okay, which was the most accurate definition that we had? And this is the one that it's gonna go with. I want you to think about this for a second. Pretend you didn't see that image. if our machine went out into the world with this definition of a dog, are there any other types of dogs you can think of where this wouldn't work? Not including the golden retriever puppy. Just shout them out. Like, what are some dogs that don't fit this definition?
Pugs.
Mm-hmm. Yeah. Any others?
Shih Tzu.
Yeah. Yeah, because they're not big. Okay. So what would you change about the way that we train this robot if you wanted it to be able to detect pugs and shih tzus and golden retrievers? How would you fix this?
Just keep throwing more dogs at it until it learns every type of dog possible.
Yeah, so we would want to include all those types of dogs in our data set, right? Like if we included golden retriever puppies and shih tzus and pugs in our training data set, then our machine would have to like come up with a definition that includes those. So the fact that it doesn't work on golden retrievers is kind of our fault, right? Like we didn't include those images in our data set. So you may hear people talk about like bias in machine learning. You could think of this model as being biased against golden retrievers. And this is one way that you can end up with a machine learning model that is biased, is we didn't have diversity in our data set. If we wanted this model to work for all types of dogs, we should have included all types of dogs in our training data set. And this will come up again when we're talking about machine learning in medicine. If we want our models to work for all kinds of patients, we have to make sure that we include all kinds of patients in our models. Does that make sense? Cool. Great. Okay.
Question actually.
Yeah.
Okay, so if you go back to Sammy's question, like how is that really learning anything if you're just really giving it every single rule that it could? Like you're giving it all the options. How is that not just listing all the rules?
Yeah, good question. Okay, so I guess an important thing to note here is that we would want it to be able to show it like golden retrievers, pugs, whatever, but then if it sees a different dog that is like a golden retriever or a pug, we want it to also work for those. So like, yes, if we showed it the same image, like, yeah, it didn't really learn anything, it just memorized dogs. But we want it to learn patterns that are generalized. So then when it sees a dog that it's never seen before, it can also recognize that.
Got you. Thank you for that clarification.
Yeah, good question, Juliet. Okay. All right, so one thing that I want to be clear though is that like our machine is not actually that smart. Like a human baby can look at just like 5 or 6 images of a dog and maybe get like a sense of what a dog is. But because our robot is like not as smart as a human, we like typically need a lot more data. So like in the interactive thing we're going to be doing, we'll use 100 images. You'll see like typically like in the hundreds to thousands of images. Yeah, okay, and then again, kind of to touch on Juliet's point, there's 2 different like phases of this. There's the training where we're giving it all these images so that it can learn. And so what it's doing in that is it's going over all those images over and over again, trying to figure out a definition that works. And so it's kind of just like guessing random things, testing how accurate it is, and it's going to just go with whatever is the most accurate thing. And then there's the testing phase. That's where we want to see how well does our model work on things that it's never seen before. Because if it works on the things that it's seen, then like, yes, that's not really learning. It just memorized that. So we'll come back to this again in the interactive part. So training phase, testing phase. Okay, and so we're going to be training a medical machine learning model. This is an example of something where you can use machine learning to do diagnostics in medicine. So for example, you can feed in a bunch of like melanoma images, so pictures of benign skin lesions or whatever, and then like malignant skin lesions, and then have this machine go out into the world and look at like new patients and diagnose whether their lesions are benign or malignant. Okay, so thinking back to the golden retriever, do you notice anything about this data set that is potentially problematic?
They're all white patients.
Yeah, they're all light-skinned patients. So how do you think this is going to do if we showed it a picture of a dark-skinned patient?
Probably will perform pretty poorly.
Yeah, it's probably going to be less accurate. We can't really say like, is it going to over predict benign or malignant? It's like probably not going to work as well. So these images are actually from a publicly available data set. They're not like cherry picked. Like this is actually what the whole data set looks like. So this is like a pretty common problem in ML. And just something that you should be aware of. And like, it's hard to say like, why does this data set exist that only has like white patients? Like someone just like didn't bother to include pictures of dark-skinned patients. And so if you're passionate about like ethics and ML, like this is potentially like a research area that like you could go into. Like maybe there's a discovery project here. I don't know. But yeah, okay. Another question that I want you to think about is because we need all this data, what are some types of medical problems where like we could use machine learning, and what are some areas of medicine where like it would be harder to use machine learning?
Maybe psychiatry. There's less
Yeah.
images. It's more based
Yeah.
on personal responses.
Yeah, so areas where you don't have like good clean data, definitely. Another thing is like rare diseases. Like if there's only like 20 patients in the world who have like some disease, it's going to be hard to get enough data to train a model. So machine learning is really good for areas where we have this like clean data, and there's a lot of it. So that's like one constraint on ML. So going back to that dermatology thing, this is like something that people have published a lot of papers on. And like, I know for a fact that like at least one of these had like a pretty homogeneous, like not diverse data set, and they still get published. So now that you have some background on this, you can be more critical about this kind of research when you see it. Okay, I also just want to say that like it doesn't have to be images. We've been talking a lot about images, but it can also be other kinds of data. So like this is an example where like you could use like the age of a patient and like respiratory systems to like get a diagnosis. So this is like structured data tables. You can also use signals from devices. And there's like a lot of rich data in electronic health records, so like natural language. It doesn't have to be images, it can be all kinds of things. But okay, does anyone have questions on anything that we've talked about here before we move on to the interactive bit? And we'll go into breakout rooms for that, but I just want to make sure this is clear before we do that. Okay, great. Cool. Okay, so what I want everyone to do now, we're going to be training our own models. We're going to get to like a medical model, and you should have gotten an email with a data set to download. If you didn't, that's okay. I'll show you the link for that too. But first, I just want everyone to get a sense of how this tool works. So we're going to be going into breakout rooms, but go ahead and open a tab in your browser with this URL, and then go to image project. Okay, awesome. So I also just want to show you like how this is going to work. So the way that this works, and you should be able to see my TeachableMachine tab, is you're going to record a bunch of data. So what I've done here is like a sign language model. So what you can do is like show the model like a bunch of data. So what I'm trying to do here is teach the machine how to differentiate between A, B, and C in sign language. Okay, so I'll remove all these samples just so I can show you how to do it. So the first thing you'll want to do is label your data set. So I'm going to call it A. Okay, and then I'm going to show it what an A looks like in sign language. So it's like that, and you want to show it like a bunch of different like angles so that it gets like a sense of it. Okay, and then I've done the same thing for B and C. Okay, and then you want to train the model. And so what it's doing here is kind of like we talked about with the dogs, it's going over all of these images that we've shown it and trying to figure out like patterns in these images that will help it to understand what an A is, what a B is, and what a C is. And so when you're doing this, you can do this with like random objects, you can do it with facial expressions, hand gestures, anything like that. So it's going over all of the images we've shown it 50 times. That's what this number is. And then once it's done being trained, we'll see how well it does in the testing phase. Okay, so here's our model, and we'll see, like, does it detect an A correctly? Does it detect a B correctly? It's kind of struggling with that. then does it detect a C? And so you can kind of see like, what is it good at? What does it struggle with? So I'm going to put everyone in breakout rooms now, and each breakout room will have someone from the MedML team in it. I want us to think about a medical use case of this. So if you haven't already had a chance to download the data set that was sent out in the email, you can go to this link to download that data. And in that folder, you'll see training data, testing data. So kind of like how we've been doing, you're going to want to drag and drop the 100 images in each folder into like into these two classes. So you'll see they're labeled benign vascular lesion. So kind of just drop them into TeachableMachine. And then there's another folder that has just 20 images, and those are different fresh images that the model's never seen before, so you should not include them in your training phase. So we're going to see if like from the 100 images that we showed it, can it now work well on these 20 images that it's never seen? And so for that step, you'll want to upload like one file at a time and see if it gets it right. We'll go back into breakout rooms to do this. And I just want to make sure no one has any questions about this. And the co-host will be able to help with this as well if you do have questions. All right, so how did that go for everyone? Do like a thumbs up, thumbs down. Okay, cool. Yeah, I heard some people had technical difficulties, but hopefully some of you were able to get to this point. And I think for most people, the model actually works pretty well on the fresh images that the model's never seen before. So that's pretty cool to see, right? But keep in mind that like there's a lot to machine learning that like this little toy like doesn't let you really play around with. There are like advanced features like here that like we didn't really get into. But these things like epochs and batch size and learning rate, these are all things that we will have like more workshops to talk about. People did bring up like some really interesting things in the breakout rooms. So Mina had a great question. Let me present. I should wait. Okay, I'll talk about something else then. That's not as important. But yeah, Sammy asked about like how much coding you actually need to use use these models elsewhere. And that's also something that we'll have workshops on with like the actual code snippets that you could use to take the model that you made here and like actually use it elsewhere. I believe Serenity is actually working on an Intro to Python workshop, if that's something you're interested in. Okay, yeah, and then the other thing that I wanted to talk about that Mina brought up is the fact that we don't actually know what the model is looking at. So that's something that we call interpretability in machine learning. Like if you wanted to know why is the model saying that this is benign, or why is it saying that it's a vascular lesion? The models that we've built don't actually tell you that. And so we may also have a workshop on interpretability, just like plugging other workshops here now shamelessly. But interpretability is something that's super cool. And like, I wish we had time to talk about it, but yeah, another workshop. And that's a big reason too, that like patients probably would have a hard time trusting like ML in medicine, is because like people like things that they understand. And if we don't understand how this model works, then people are less likely to trust it. So just a thing to think about. Okay, so that's all we have today. Does anyone have any questions or comments or anything at all?
This was wonderful. Thank you all so much. I just had one question about kind of where we are with ML in medicine. I don't know anything about that. Is anybody using it in the place of a provider, or is it just used to supplement thinking?
That's a good question. So there have been examples of people using ML to do like basic diagnostic tasks. Like, for example, I removed this from the slides, but there was like this project in India where like ML was being used to screen like people's eyeballs for signs of like future blindness. And they were doing it in that case because there just weren't enough ophthalmologists in that environment to be able to do that. So there definitely have been instances where like, because of a lack of like actual physician resources, ML has been used to do diagnostics. But we have talked a lot about the limitations too. And like right now, like I think typically ML in medicine is like a tool that's used to supplement doctors. But who knows where this will go?
So I just had a question about the rest of this, I guess, course and kind of what exactly we're going to be doing.
Yeah, well, so this is meant to be like a standalone workshop to just give people an idea of like what ML is and why it's important and how it works. But yes, we do have like, depending on what you're interested in, like if you're interested in like high level things like ethics or interpretability, things like that, we'll have workshops on that. If you're interested in getting into the coding stuff, we'll have those intro to Python workshops. We'll also have like workshops where we actually get into like different types of machine learning, like logistic regressions, linear regressions, things like that. So yeah, that's all stuff that like Vinny, Avinash, Alex, Amitaj, and Serenity have all been working on. So we'll send out emails. We also will be sending out, okay, I guess I should point out this feedback form. If you have a minute, like just take a picture of that, go do that form if you can. It's pretty quick, it'll take like 2 minutes. Yeah, and then in that form, you can tell us what you're interested in learning about, because we want these workshops to be like useful to our community, obviously. So do let us know. But yes, was there something in, like specifically that you were wondering about?
Not really. I was just really wondering kind of what the path of this course was, what to expect.
Yeah, it'll be kind of just whatever you're interested in, we'll send those out, and whatever you feel like learning, we hopefully will have something to address it.
So
yeah,
Thank you.
everything Ariba said, absolutely. The goal is to have it almost like a choose your own adventure on your own time style, because it's going to be really, really tough to balance M1s, M2s, M3s, and M4s and all the different schedules everyone has, especially as M1 starts ramping up and y'all do anatomy and things like that. So really the primary goal is to have resources up that you can engage with on your own time. So you'll see in the original email, there was a link to GitHub. That's where a lot of the code will be. That's where a lot of the interactive examples that are not TeachableMachine will be. And then the goal is to have y'all engage with that on your own time whenever you can. And then every now and then we'll try to have a workshop where we can get together and work through some of those resources. But you don't have to come to the workshops. You don't have to engage outside. It's really just about whatever, getting the resources to medical students that they need to engage with this on their own time. So we'll have multiple different tracks, and it'll just be to get your feet wet and then hopefully empower you to go learn through the phenomenal resources that others have already built. Hopefully that helped.
That's also why we're recording this, is because we want stuff to be just available online so people can do it in their own time. But yeah, okay, so I want to let people go. This is just more like information about how to learn more. There's also a lot of like great online resources. I've put like a link to one here just because this is like has a special place in my heart, because this is how I learned about neural networks, is from this video series. But yeah, thanks all for the questions and for the engagement. If you have more questions, like I'll be here. I think a bunch of us will probably still be here. I just want to let people go. This is my email, and like you probably like met some of the team in your breakout rooms. So feel free to contact them as well. Cool.
Thank you, guys.
Thank you.
Thank you.
Thank you.
Thank you. This was wonderful.
Thank you.
Thank you.